Hi. First up, I'm Matan. This is Vlad. As you can guess, the presentation is going to be in English because Hebrew is the fourth language of one of us.
It's either English or Ukrainian, so you can decide.
My Ukrainian is not so good. We both team leads at eXelate. So we're going to tell our journey how we made a transition from a small company to a worldwide company with a lot of developers and customers. So, about us. My name is Matan. I'm a team lead in eXelate, a Nielsen company. And my team is responsible for one of our apps. I've been at eXelate for about 3 years, and this is the nice LinkedIn link, and you can just search. Okay?
Yeah. Hi, my name is Vlad, and I'm team lead at eXelate. I'm leading the infrastructure team, and I'm 1.5 years in eXelate and basically in Israel. So,
okay, a little bit about eXelate. Founded in 2007, based in New York and Israel, big data company in the ad tech world. In March 2015, we've been acquired by Nielsen, and we're developing the Nielsen Marketing Cloud, which is used by entire Nielsen organizations. For those who don't know, it's few tens of thousands of people. Okay, so I'm going to hand it over to Vlad, and I'll return for the second part.
yeah. So the agenda of our talk will be next. So I will try to explain what was our journey after acquisition by Nielsen. So what did we need to build? Which requirements did we have to build our platform? Why current common solutions didn't help us, and why did we need to build our own solution? Then we'll go through the architecture and basically what did we build, and how did we manage to build the shared components library that is open sourced inside of our company, that each team, each developer, web developer can contribute for. And then Matan will go through deeper look how we are creating new applications under our platform, and which challenges, problems do we have, and which solutions do we plan to implement to solve these problems. So basically, the first thing, why did we need to build something? In 2015, eXelate was a pretty small company. We had one product with 200 customers and around 10-12 web developers in Israel. And after acquisition, after 1 year after acquisition, now we have 6 different products, 2,000 customers, and more than 40 developers all across the world on 3 continents. And the scaling of development process, it's pretty complicated task. And that's why we started to think about the new infrastructure and new architecture of our system, our platform. And we started from some requirements. What do we want to build? So the first thing that we decided that we want to build some platform which will consist of different applications inside of it. But from user experience, it should work like one big web application. So, which means that from user experience perspective, users just should go for different menus in the system, and all the look and feel and everything should be like it one big system, but under the hood, it should be, sorry. Okay. So, but under the hood, it should be different micro applications. Each of them are developed by different teams, and each of application it's a set of different screens. So, requirements for this is next that each application should be able to develop on different repositories. Each application should be able to deploy independently without harming any other applications around it. Each development team for each application should be able to choose their own technology stack. can be Angular, Backbone, Ember, Vue.js, React.js, and so on. Because the system in the result will be very, very big, we don't want user to download all the code for the whole system at once, so each screen should be loaded on demand. And we don't want to rebuild the whole platform for adding new application. We want to be able to just to go to database, add new application, and user will get it automatically without any rebuildings. So, why current solutions like Webpack, which is the most powerful module bundler in front-end world for now? I'm not touching anything. Why they are not working and why it doesn't meet our requirements. First of all of these solutions, all of these solutions like Webpack, they are module bundler and not application bundler. So it means that all of them should know about all modules that you have on the build time. So you cannot add on runtime some new module that Webpack didn't know about on the build time. And it doesn't meet our requirements. It has ensure that can load some modules on demand, but it's still not everything that we want. But from other side, Webpack is cool, and we want to use it because of all of the requirements that you can require image, require less files, because of loaders, plugins, minifying, and all of the stuff. So what is the solution? How can we combine to use Webpack and meet our requirements? We built the next architecture. So browser loads the infrastructure layer. So infrastructure layer is some project which is built with Webpack. It's loaded on startup on index.html, for example, and it manages all of the host functionality. So it's like login, logout, navigation and routing between the screens. It provides some shared libraries that are reused by different sub-applications, and we don't want to put them to their bundles and copy, for example, D3 in each of the applications. But the most important stuff that it loads each screen from each applications on demand. So, and as you remember, on the build time when infrastructure layer is built, it doesn't know which applications will it have in production or when it will work on runtime. So for solving this, we're using AMD, asynchronous model definition, and Require.js as the most popular library that supports it. So what does it give us? That we can download some module from external, for example from CDN, execute it on runtime without knowing about module on the build time. And each of the applications, it's separate Webpack builds that provides as the output of their bundle the structure like screen1.js, screen2.js, screen3.js, and maybe commons.js if the screens has shared modules and you want to use commons chunk plugin. So you also can have commons.js. So when user will go to screen1 of first application, firstly we're downloading commons.js and it executes them, and then we're downloading screen1.js and execute it. Then works caching, and if user will go to screen 2 and then back screen 1, we are not re-downloaded, and so on. So this architecture gives us the ability to add applications on runtime, and each application can use inside of it any technology that it needs, and all the features of Webpack, which is cool. So, but another problem that we have, because all of this happens on runtime and infrastructure layer has some shared things, we need somehow to build the communication that when application was loaded, we want somehow to require or use some modules and components from infrastructure layer. How do we do this? Basically, we're hacking a little bit Webpack. So the require functions, when you're using commons.js notation in Webpack, under the hood, it changes require function to its own implementation. If you saw the Webpack output bundle, you know what I mean. So we are exporting from our infrastructure layer to global infra object in the window the require function of Webpack. What does it give us? It gives us that each application that we are loading on demand in runtime can just say window infra require and the module. So, and it will return the export of your module. on runtime synchronously. So it means that each application can use any module from info layer in runtime. And also we're exporting AMD-defined function from require.js because in runtime module should wrap itself with the AMD-defined function and components that we will talk about later. So infrastructure provides base screen interface, which means that each screen, if it wants to be loaded and executed, should extend this interface. Interface basically is very simple. It gets two main things. It's container element where it should be rendered inside of the page, and the user context model. And it has three main methods: initialize, render, and remove. Initialize, it's a method that screen can use in lifecycle of the screen before rendering if you need to download some data before rendering or doing something. Then render, basically it's the business logic of the screen, its rendering part, where it should use the container element. And remove method, it's something that screen should implement, how it will be removed when user will go to another screen. So, and on the left side you can see that we're just using AMD-define as a wrapper of my module. Then my screen extends base screen that I got from info require base screen and returning the screen. So, for example, implementation of screens on different technologies. For example, this is React. Render method will be React DOM render to this container element of some of my high-level React component. Remove React DOM and mount component and node. If it's Angular, it will be Angular bootstrap to this container element children, some my Angular application. If it's vanilla JS, you're just getting this container element and appending something under it. So it's pretty straightforward and gives us ability to manage the screens with one interface, which are inside, written on different technologies. The building of the app, as I said, each application is built by Webpack. The build itself is very, very straightforward. Like we have entry points of screen 1, screen 2, and screen 3, for example. And only one thing that we need to manage is that because of in runtime we're downloading the screens from different applications, which it means that on one page we're managing a couple of Webpack builds. And in this case, each Webpack build exports to global JSON-P function with the same name. So if we want to manage and to not have conflict between them, we need to add unique name for each application of the JSON-P function. Everything else is straightforward, and the result of the build is very common, like screen 1, screen 2, screen 3 JS, commons JS, and some static assets if I have them. How do we serve and deliver all of this stuff? So we have the S3 buckets with subfolders for each of the application and infrastructure layer. We have CloudFront CDN that serve this S3 and deliver the files and all the assets to the browsers. And we have deployment service with that exposes some HTTP API. And each application, for example, application 1 want to deploy the new version. It makes this build and pack it as zip, put it with HTTP API to our deployment service unzipping it, making a cache busting, calculating the hash for each file, and upload it to the separate folder for each application in S3. And users get the new version of application, which means that, as you can see, each application has fully isolated flow without, so each application cannot harm any other applications. From other side, if in some application in screen 1 I change some CSS, so in the result user will re-download only screen 1 of this particular application without re-downloading all the application around it, which is pretty good and it meets our requirements. So now stages for Matan, and he will show some quick demo and we'll continue.
All right, thank you. Thank you, Vlad. So first, let's do a quick demo, just so you know what we've been talking about so far. So this is example of our app. Okay, even on this stage right now, this is, as you can see, a list page. We have at the top here a navigation bar, and here a list that we show some stuff. So even this screen itself, it's React, the top layer here, and the bottom is in Backbone actually. So if, for example, we show the React developer tools, which I hope everyone is using, you can see the header is identified. It's here. Navigation menu, everything, and now we have view container. So in the view container, we have a body container, which is exactly this, what's below the blue bar itself. So you can see there's nothing beneath it. That's because it's not there. So Reactor Tools doesn't recognize it. So, okay. So let's say I want to switch between apps. Here I click on this button, I have an option to go to basically different apps. I choose the first one. Okay. So here, this app itself, now we're at React. You see, the connect is here, everything is here. This is a regular React app now. I can use everything I want. Okay. So, we have a recommended stack for our apps, which is similar for what you saw before. We have React for the view layer, Redux for the data handling layer, less or SAS for the styles. And we use a combination of tape, enzyme, and JS DOM for testing. That is unit and integration test, for those wondering. Okay. We also have a style guide. Almost seems like a trend. As a style guide, as you heard, it's a set of rules that each app, each widget, each part of the screen needs to follow the rules. So here it's an example of navigation rules. You can see you have exact color, exact pixel, distance, fonts, everything you want. And we also, as was mentioned before, have a shared components library. Ours called shared front-end components. So the components itself, as you saw, we recommend a stack. So the shared components themselves are also written in the same stack. That is, they're in React. They use less, usually, use testing, as we saw before, tape, JS DOM, enzyme, with 100% coverage. It's entirely open source. It means that it's on GitHub, on a private repository. And every team throughout 3 continents can contribute using pull requests, as long as they pass the pull request. So the shared components, what's the best way to show them? React Stylebook. So we also use React Stylebook. We develop using it. This is the best way to develop components in an isolated environment. So I can even, show you just a quick part of it. So this is a storybook, as you saw before. You can play with it. You have everything here from the most simple button, the most simple checkbox. So if, for instance, I go to a checkbox, I even have, for developers, checked, not checked, and controlled elements as well. I can play with it. To the more complicated, for instance, detail page, as we just saw, which again, it's totally dynamic, and we can live edit. So you see this component specifically is also used within the app itself. So this is taken directly from the shared components library. So React Storybook, again, we use it as developers. We also share it with the product team. It's a very good way, an effective way to share data across different parts of the organization with the R&D in the product, and make sure there's no data loss during it. So, how an app is born? First thing an app needs to do is to declare itself, as you saw before. This is our app, it's a React app, and it uses Redux, so we also pass the store down the line. So, how can you use the shared stuff that we just saw? So, this is a screen capture from Chrome DevTools of the window. So, in the window, there's the infra. Inside the infra, we have all the stuff that we need. We have the AMD defined that you saw that we need to define the screen with. We have the app version, we don't really need them, but components. This is again where we pull the detail page, the button, the drop downs, and everything. We have the libraries, React Redux. We also have React in it. So that means there's only one big dependency in the app. No micro app need to import it. It's just in the system itself. We had the require here that you heard about, the router, the breadcrumbs, which is where you are, and of course the version. So we usually recommend a centralized place, some infra facade that you use for all of your requiring of the infra itself, which means if there's any change or something along that sort, you can just change to one place and that's it. So here, this is of course regular JavaScript. We import from the global itself, from the window, infra, require, base screen in this case. We have a define, router, all the stuff that we saw in the window itself, including the components here. The short components, button, and drop down. Okay, so you heard that infra gives us the React, Redux, all the dependency of the big libraries. That means the infra itself have to be a dev dependency of each micro app for testing. So you can see we use JSDOM. In JSDOM, here, just inject the infra vendors, which is the vendors, and the infra app itself. And a dev dependency, of course. So in order to make, we have a very streamlined process of creating apps. We have a cookbook, a very simple one that each new app that wants to can just clone it, fork it, whatever they want. They also can also use the shared components that we already saw and were amazed by. We have the shared components, and we have an existing CI pipeline which they can also leverage. So with all of that, with all of these capabilities, it can take one day for an app to, with the backbone of the app, to be in our integration environment that we currently have, with testings, with everything. So some challenges that we still face. And the next slide, I'll say how we approach them. So number one is contracts. Okay? So in this case, we have radio button component and another radio button component. We wanted to change the contract from data to radio data. So that means that every app, widget, whatever that will use this will break. So how do we do it? We currently do it with version, which I'll talk about in the next slide as well. Another issue that we have, there are two issues that are connected to one another. One is CSS isolation. So each app can import its own less using you know what capabilities. So if for some reason someone wants it for his or her app, all divs will be hidden. It's very, very important to him. So that means most of the system won't be usable anymore. Another thing which is similar in concept, is the app's JS isolation. So if someone does window.react equals some kind of empty function, from that point on, once that app is loaded, React won't be React anymore, it will be an empty function. And last is limited to infra-vendors dependencies. So if someone wants to use a different version of React, different version of Redux, a different version of anything other that we provide, they need to add it as a dependency of their own. So in that case, we return to problem 2 and 3. If someone injects Bootstrap, they want Bootstrap in their app, again, it's very heavy and can cause clashes with other apps. So how do you face all of this? Okay, first of all, version components, as I mentioned before. So production development has different versioning. If we do a breaking change, we change the major version. Second thing, we have an integration environment, which already has multiple apps. Most problems, if not all, are already caught on that environment. We also have development conventions, such as we use standard.js, which is very, very usable. And yeah, for those who don't know, it's used for JavaScript. It's opinionated a little bit, but it's it's helpful in the long run. Each time a new developer enters and sees the code for the first time, they can usually get into it pretty fast. And one thing that we want to achieve in the future, maybe using a Webpack or something of that sort, is real-time code analysis. So we'll build something that will go over your system, your code base, your source code, and check that nothing affects the body, nothing affects, nothing can break any other app. So this is, of course, a mandatory slide. Okay. We're hiring. This is for those who don't know beer. Welcome. Goodbye. And thanks. Yes.
You mentioned cache busting. How does the infra app, when there's a new version with a different hash, know to use that version and not?
So, first of all, on the builds of each application, we are adding the chunk hash at the end as the query string param. And we're using assets plugin, which calculates the hashes of each screen. Then, when application deploys itself to the infra, we are getting all of these hashes, storing them in some kind of database. And when user will refresh the page, we are giving him all hashes of all screens of all applications and adding them as cache buster.
So the server is...
Yeah, server.
I have two questions. The first is related to Webpack. So you guys basically monkey patched Webpack's require API,
No,
which is cool. I suggest you guys maybe contribute it as a plugin or something like that to Webpack, especially now with...
Basically, we didn't monkey patch it. So we're just we found out that Webpack, when you're using require in the bundle, it uses Webpack require context function. And then it gives the ID of the module. You give the string, and then it moves the string to ID, and then goes to the ID of this module. So we're just exporting this function.
Okay.
So we're not changing Webpack at all.
Okay, my mistake. The second is about the limitations. So you mentioned, yeah, exactly this. So one way to put it, the last bullet, limit to intra-vendor dependencies. The other way to look at it is that I can basically require, if I have an application, I can require something with a typo, and there is no way to statically analyze that. And I will not discover that until runtime.
Not really. Yeah, you have this part that you are using Webpack for frontend as the dev dependency, and in your tests, when you're requiring it runtime, you will see it on tests.
Okay, so that's your mitigation to the problem.
Yes.
You write this, right?
Yeah, but basically that's a problem. That's the general JavaScript problem, that a lot of things you can find only in runtime. That's why you need to write tests, and if you're writing tests, you will find this kind of problems on this level as well.
Each app that is hosted in your infra has only one endpoint, like only one route?
No.
Or can have like multiple routes?
Vlad, please repeat the question.
If you do, how do you manage those inner routes?
Yeah, so the question is, can one application have only one route, or it can multiple routes, and how do we manage it, right?
Yeah.
So yeah, here as I showed, that each application, we have like the smallest unit of our system is screen. Screen, it's like screen that we see currently in the system. So each application can have, yeah, this is the screen. So each application can have a couple of screens, and when application deploys itself, we understand which screens does it have. We register them also in database, and we have management, like this user has permission to this screen, this user has permission to this screen, and when user goes to this screen, we are using HTML5 history API for soft routing. So we are changing the route, we understand that we want to show this screen, downloading this screen, and rendering. And then basically, if inside of the screen, like application has very complicated screen, and if application inside of the screen also wants to separate it to a couple of bundles and download them asynchronously, they inside of the screen can use require ensure of Webpart. So because they are building all of their application with Webpack, inside of the screen they can use require ensure, and when I will go to their screen, we will download the screen, show the screen, and then screen itself will manage how to download other parts for it. And all of them are hosted in one CDN, so we don't have any problems with downloading from different locations and so on.
Yeah, because of the deploy service, which is somewhere.
Any other questions?
I have another one.
Yeah.
Is the reason you chose to one of the stuff that you said in the beginning is that you wanted to host all kinds of apps like Bootstrap, React, Backbone, React, Angular, or whatever. Was that something that you had to do because of current legacy code, or was out of the box, like as a fresh development, I still want this capability? Because I'm sure that this was a big chunk of complications to build that infrastructure.
So we had two main reasons. The first reason that we had legacy application which was written on Backbone, and all new stuff we wanted to write on React, so we needed at least to mix them too. And the second reason that the idea of Nielsen Marketing Cloud, the product that we are building, is to combine a couple of different applications from the Nielsen inside of one product. And the idea was that some of another sub-company of Nielsen in different country, they have already Angular application, for example, and they want to integrate to our product. So we don't want them to rewrite all of their application to React, so we should be able to give them ability to use Angular that they're using. They will just change styles and some functionality, but basically inside of it, it will be their application on their technology stack. And the third thing that we're looking to the future, and maybe in a couple of years we will have something, we for sure will have something more cooler than React, and or React 2, even better, yeah. Or React 2.0 that will break everything on React 1, and we want to support it in the future as well. That new application will be able to write on something new.
All right.
Okay.
Are you ready?